Hello, doctor. How are you? Today I'll be talking about the config YAML. First, we'll start with the trainer type, which is PPO. Since I'm using assumption and the values are always constantly changing, DQN seems very bad and a bad model to and like a bad type to choose. So I chose PPO, the normal version. Each agent, blue and red, have max steps of 2 million, meaning after 2 million steps, the training stops. The time horizon is basically um, like after 128 steps, it looks back and it asks it it asks itself if I did everything right, if there's something wrong. Now, now this is good for my project. If I had it a bit little less, it would be very it would be very like bland, like it wouldn't be like too well. So I chose 128, not 512, as it is like it is like the middle version, which is I think best for my project. Summary frequency is basically after 10,000 or each 10,000 step, they give me a summary on the command prompt, which I was training it on. The checkpoint interval after like 500,000, they give me a checkpoint onyx file in case for example, if I reach 500,000 and I see that the scores are well ratioed. For example, if red scores 50 and blue scores 45, that's good. However, after in training, let's say I reached 1,500,000, the scores is now 500 red and 50 blue. So I have a checkpoint I can roll back on and I can resume here. Or, for example, I could stop it and resume from it. The batch size is basically how, or you know what, actually, I'll start from the buffer size. Basically, the buffer size is how much memory do I take. Now, taking too much memory makes it very slow. Taking a little, like less memory makes it very fast and stupid. So I chose 4096 for, to make sure he's training well, not too fast and not too slow. Now, the buffer size is 4096. Now, he's not going to train the whole 4096. No, he's going to take 256 of each one. So 4096 divided by 256, that's 16. Um, that's like 16 batches. So he picks it apart and he breaks it into 16 batches, which is 256 each batch size. Learning rate is basically how fast he learns. If I make it too high, it becomes explosive, weird. He might even start doing stuff that I didn't teach him. For example, I had it at 0.1 at one point. And um, so the red team found out that if I jump on his head, I can jump on the stands or like the bleachers in the game, and I can hide there and snipe them from a higher range. So he has the high ground. So keep in mind, I did not tell him to do that. So I had to decrease the learning rate. In beta, is basically entropy. It's uh, it's basically how much he should explore. Like he should explore. Okay, maybe I do this, maybe I do that, maybe I should aim, maybe I should move to the right, maybe I should cover then aim. So he's exploring other ways, other grounds and stuff. So it's basically entropy, from what I understood from it. Um, Epsilon. Um, it's basically the change of each episode. every time red wins or blue wins, a new episode starts after it and it restarts. So epsilons basically don't change the scenario much, only change it by 20%. So basically, if blue is walking, and like he chooses like the right lane, and then the left, and then the right. He says only change 20%. So instead of like going to the right one, just go to the right one and then to the left, not right and then right. So like only change 20% of what you did to see if maybe you get a higher score or something like that. Lambda is basically it's basically split into two. So if I have it high, everything becomes consistent. This causes bias. If I had it low, the variance between like the variance would like between become high, and it becomes very random, and I didn't want that. I wanted everything to be the same as it is. So I wanted him to be a sniper. I want him to be a sniper. So that's why I had the bias very high, because it's like consistent, even though um, this causes consistent like mistakes. Over time, they will learn it. This is very important right here, because this um, is connected, or like it's connected to this right here, these two. What happens is the number epoch, it basically trains the batch size 3 times. So the agent trains the same batch size 3 times. So the first batch size 256, that's 3 times. The second one 3 times. The third one 3 times. So if we do 4096 divided by 256, that's 16 times 3, which is the three. Learning 3 times the same batch size 256. Uh, that's 48 like 48 updates learning. On normalization, this is also very important, because in my project there's health, which they have it as 100. There's the damage, which they have it as training, and like there's shoot damage, for example, like 20, 25. So I have to normalize them, so to keep it well made and not make everything like, for example, I need them to be normalized to 0 and 1, so that it becomes more stable and not like weird and random, because he starts like valuing stuff that like he shouldn't value more than the rest. Hidden units, this is also very important. Why? Because hidden units is like the brain. He has 256 neurons. So in like I'm like using these units, he thinks and like remembers what he did. Like for example, he thinks, okay, should I run, shoot, run, cover, shoot? Like, should I try and cover? Should I try and run away? Should I try and take cover, take point? So this is very important. This, of course, like the input goes in, and like I'm using like the 256 units. They study, and understand what's going on. Num layer is basically just how deep this hidden units is. So like there's 2 layers. So the first 256 units, he just thinks, okay, what happened? The second layer, which is 2, okay, what should I do? For example, like that. These are like the reward signals, basically like the externistic. So like add reward and stuff. The gamma is also important, very important, especially for my project. It's like mainly one of the most, like not the most, but like one of the most important stuff, because he thinks of future rewards. For example, let's say the blue was behind a rock, covered, and red was also behind the rock. So like in front of blue, is the rock, and behind the rock there's a red player. Now, like if he stands up and tries to flank him, so like if he stops being covered and he runs towards him, he's gonna get hit once or twice. Now that is a penalty. However, he thinks for the future. Okay, if I run and I run towards him fast enough and I can kill him, okay, maybe I'll be penalized for for getting hit. However, I'll get a huge reward for killing him because I know that my damage is stronger than my damage is stronger than his. So I kept it a bit high for that, and it can also be used like in on future rewards. Like for example, okay, if I stay put, he might come near me and hit me, even though I'm staying in put. Like for example, in red, if he stays in the same place, okay, okay, he might shoot team blue, get one hit or two hit, but team blue will get closer and he'll hit him and kill him. So that's not valuable for it's not viable for him. So he moves, even though there is a reward on the table for him. There is a reward on the table, but the reward is not as big as getting that penalty after he dies. So that's why he moves, even though there's a reward on the table. Strength basically is just the reward, the add reward times 1.2. So for example, if he gets 0.5 reward for hitting someone, that's times 1.2. And if he gets 0.5 penalty for getting killed, that's times 1.2 as well. So the reward is basically is multiplied with the strength. Now I did this for the red agent because I needed him to strengthen up, because in the first couple of trainings I had him at 1, like like I'm the blue agent, and he was doing random stuff, like he wasn't shooting, so I had to strengthen him up to 1.2. Here's basically the same thing as you know the rest. The only difference is the strength. Uh, both have both have same max step, time horizon, summary. Now I have the checkpoint interval at 300 and here at 500. Now this doesn't, for me this doesn't really matter that much for me. Because in my project I needed the whole training to be finished so I can use it. So him learning stuff that he shouldn't learn at the end, it made me redo the learning. So I didn't use this because I needed the learning to be finished. I don't want to start from a checkpoint and then redo it all over again. No, because I knew that if I redo it over again, it's gonna do the same error because he's gonna find the same tactic. So what I did is I had the first the first 500k of him learning how to walk and how to move, stuff like that, and then from that I changed it into resume, and that resume is in laser tag 2, laser tag 3. For example, here it's laser tag 3. Also, sometimes I just start it all over again, maybe because I felt like the resume thing. I'm resuming into the same the same part that 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 I did. I thought maybe there was an error there, so I basically just removed resume and just made it all over again. So realistically, checkpoint interval, this needs to be 300 as well, so that in the terminal checkpoints on both of them enter the same time. So basically there's a checkpoint at 300, so I can use the brain of it when it finishes. Same thing here. but I can't keep it like I'm at 500 if I want the whole thing. If checkpoint doesn't matter to me, because there was some scenarios that I don't need checkpoint. I just need it to be fully correct. Seed is basically random, so don't use the same stuff. If I put it differently, it'll become deterministic, and that's not what I was doing. I was making it reinforcement learning. Number of ENVs. Number of ENVs. Um, Basically, I wanted to put this at 5,000, but I couldn't because my PC didn't take it. This is a joke. It's basically how many simulators. I have one simulation. I could put four. Better training, faster training, more info. But my PC can't hold that much. So I used one. Now, if I had a small project, maybe I can put it at four. However, I had many assets, Unity assets stuff, many characters, and I had many like space, I had many like factors going on inside the project that made it very bulky for me to train more than one. It was so bulky that I had to make a demo on Playground because it kept crashing. So I had to make a demo on Playground, and they trained on it, and then I put it inside the on the main one, which had all those animations and all of those stuff, all those planets and different types of assets. So ENV path is basically Unity is open. I don't need you to um, uh, like uh, I kept it null because there is a path. I don't need it. So basically, learn from the terminal, or like learn from the other stuff. Like there's no need to use ENVs. If you know web, you know what I'm talking about. Of course, they are different from the NV here, but you get it's the same concept. Anyways, engine time scale. Now this is not important because I can go to project settings inside Unity and change it to 20. So it's not very important. However, I put it here 20 because I could not be bothered to change it every single time, 20, 20 every single time. So I just put it here so that it automatically changes it to 20. Capture frame meaning I force it into 60 FPS. Don't want no less, no more. Width and height, these, every time they capture a frame, the width and the height of the image is changed to 8484. So, what we see, humans, 4K, each eye. What this sees, 8484, which is 60 FPS also. So it's basically the eyes of the AI, of the agent, and the image that they see. For example, like the eyes, I don't know, let's say if you look straight forward right now, and I don't know the height of the width of how much an eye can see, but here it's only 84 by 84. Quality level, I kept it low, even though if I put it at 3 or 4 or even 5, it would have been amazing for it. However, I wanted something fast, not slow, because if I increase it, that means it needs more and my PC could not hold that much. But if you increase it, you make it more smoother. No graphics, false. And here's why I kept it false. I didn't need it, basically. It was not needed to me. On checkpoint settings, this is here. So after the checkpoint interval, here's the checkpoint settings. The run ID, it goes back into run ID. Initialized from, I kept it null. However, I can't change this. I could put it, for example, laser tag 3. So it takes from laser tag 3 and it makes laser tag 4. So let's say I train laser tag 2. Finishes. Now laser tag 3, but I want it to be initialized from laser tag 2. So don't restart it, just start from where laser tag 2 finished. And that's this. Load model basically, uh, yes, I can put it true if I didn't finish laser tag 2. For example, if I finish, like if I reach 1 million and the max step is 2 million, so I had another million and I was tired, turned it off. I can turn it back on when I'm like back like on keyboard. Load module true, resume true, so that it resumes laser tag 2 from where it left off. This is a very good, and it helped me a lot because every training took like 3-4 hours. So, and I didn't have 3-4 hours free back to back. So I had to train from time to time, which is this. This is very good. Force is basically I have to force it to open Unity, force it to open that. I did false because I have it already on, and I have it I have the training on the terminal, so there's no need for that. I didn't really focus on that very much because I already know how to open Unity and open the play mode, so this was not needed at all. Train model, of course, like I don't need to explain what this does. Basically, train the model. Inference, this is used only if you have a fully functioning Onyx or a checkpoint on it, but like it is fully functional. I like my statement still stands. Um, it's basically stop training. I can also do this on Unity, not just here. Basically, use the Onyx file. Don't train. Only use the brain and don't train. Basically, you finish training. Now it's just now to perform. Now this is basically performing. And this, for example, when I use inference instead of train, it is 10 times faster because he's not training, he's not getting too much input, he's just basically performing all the time. So it's super fast for him. Results are stored in results dir are stored in results. Of course, I have many other models. Torch settings. Now, of course, I use PyTorch since I have NVIDIA here and on my PC. I kept it null because basically what this does, when it's null, it asks, okay, what's the best component on the computer that can help learn the fastest? Is it the CPU or the GPU? And I kept it null so that, Torch chooses what it wants. Debug, I kept it false because I was debugging. I didn't need it to debug. And it was very slow when I put it on. And I mostly, it's not about how much he learned to me. It's about I wanted the scores to be aligned. So even if red was stupid, however, the score for me was 500, 450, or 450 to 300. It was okay with me because it's not about how much smart the AI was. No, it was very different. It's about how much aligned these two behaviors, these two agents, blue and red, were together. And this was really hard because it was impossible to get the same what you call it, the same score. Each one was different in the code, and not only that, it has it's not proven, but it is known that the blue agent was better than the red agent. For why? Because the blue agent was more favored by the AI because its form that was rusher, like its role was rushing the enemy. It's very favored by AI. However, red agent wasn't very favored because red agent was the sniper, and not only was not favored, being a sniper is very tactical and very you're always thinking and stuff, and it wasn't like blue agent. Blue agent is just basically rush, cover, and rush and kill. With red agent, he had to think, okay, he's behind that rock. Am I standing very far away to get like the long range kill and stuff like that. So it was very hard for red agent. I had to power him up very much so that it could be a bit equal to blue agent. Blue agent was killing him. Like I remember there was a score with 1,080 to blue and 3 to red. Yeah, so like blue was basically just going in, killing him instantly. So I had to make him OP so much that he started killing blue more. So I had to nerf him a bit and make them very similar. And I had to put cover so that blue agent can move safely and not get hit. Because if there's no obstacles in the way, red can basically just snipe every single one of them, like from a very far range. So putting rocks, which are cover in the game, was very good for blue. So that's basically the whole .yml. You know, um, there are different stuff that I didn't add here. For example, um, here I can put inference. Not inference. What was it? It was a train model. I can put it as false. And stuff like that. But I didn't really use it because it was already in Unity. I can just change it from heuristic, inference, default. Default is basically I let him choose. So that was basically it.